All right, this video is for students who are going into honors algebra 2, and we're going to dive a little deeper on the kinds of angles you can have inside of a circle. And so this is a text that I found online that does a really good job of explaining things. Obviously, in your problem book, you've got problems to do, but without me in class at the board every day, it might be tough for you to understand these concepts. So you want to do a screen grab from here, take a picture. We are talking about now inscribed angles. So we've talked about central angles. Central angles are the angles that have their vertex at the center of a circle. An inscribed angle is inside the circle. It's inside the circle, but its vertex is on the circle itself. It's not at the center, it's actually on the edge of the circle, on that circumference of the circle. And so when we look at this angle, we can see that it intercepts an arc, much like a central angle does. So the arc that is measured by the central angle is that same arc that's measured by this inscribed angle. And so what this exercise asks us to do is to take a look at the different angles and use tracing paper or a protractor or some other way to measure the different angles and see how they're related. And in all three of these circles, if you were able to zoom in on those and actually use a protractor, you would find that we know the central angle itself. We know that the central angle being this one right here, and the measure of its intercepted arc, the measure of its arc, those two are the same. They're the same. So central angle equals the measure of the arc, and they're both measured in degrees. But so how is it that we can find a formula for the intercepted arc from an inscribed angle? And were we able to measure these with protractors, we would very quickly find out, and consistently, that an inscribed angle equals 1/2 the measure of the arc. Okay, so the central angle is straight up the same measure in degrees. The inscribed angle is 1/2 the measure of the arc. And you can see in all three of these examples that the central angle is larger just by looking. I know we don't trust our eyes. Definitely smaller. And if you look at this example here, you can see that all of these are inscribed angles, and they in fact look very similar and are in fact equivalent. Definitely. So an inscribed angle equals 1/2 the measure of its intercepted arc. So let me jump over to another screen and let's look at some examples. So here's some practice. So in the first circle here, in our first circle, it says, number one, give the measure of arc AC. Well, we know that the central angle here is 130. So arc AC, that goes all the way around there, has to be identical in measure to its central angle. So arc AC is just 130 degrees. And arcs, again, measured in degrees. Don't forget the degree symbol. Now they want to know, what is the measure of this angle, CDA? Now, what kind of angle is this? Is it a central angle? Does it have its vertex at the center? It does not. It does not. It has its vertex on the circumference. That means it's an inscribed angle. CDA is an inscribed angle, and that means its measure is 1/2. 1/2 the arc. So 1/2 of 130 is 65. So let's look at EF. EF is here. That's a chord, right? Chord of the circle. It has its endpoints on the circumference of the circle. It does not extend beyond. What is the line that goes 2 points on a circle and keeps going? It's a line. If I drew in a line here that kept going, what's that called? It's not a chord because it's a line. It's a secant line. A secant line. Yeah. So, but this is not a secant line. This is a chord, and that means here's an arc between E and F. And we want to look at, well, how do we know what the measure of that arc is? Well, here's the central angle, right? Right here. And we don't know the measure of that central angle. But here's the angle we do know the measure of. Measure of this angle is 15, and that is our inscribed angle. So if the inscribed angle is half the measure of the arc, then the arc is going to be twice as large as the inscribed angle. Okay, so this is going to be then twice as much as 15 rather. It's going to be 30 degrees. And so now it's asking us, well, then what is the angle EGH? EGH over here. Well, I know EGF is the central angle. It's going to be the same as the arc. So EGF, this being the diameter measure is a straight line. So these two angles are in fact supplementary angles. They add up to 180, and that angle then is going to be 150. And so then what's the measure of the angle EFG? EFG, and let me clear this up just a little bit because we're got a lot of lines going on over here. EFG. That's this angle here. We know that this one's 30. What is it? Well, do we know anything about this triangle right here? A central angle, by definition, has its vertex at the center of the circle, but its legs are radii of the circle. Here's a radius, and here's a radius. And radii are equal all the way around the circle. So this and this, FG and EG, are congruent. So what kind of triangle is that? It's got two equal sides. It's isosceles. So if we know everything in that triangle adds up to 180, and we subtract off the 30, then we've got 150 left that we can divide by 2. So each of those angles are 75 degrees. So angle EFG, 75 degrees. All right, so if you need to take a picture, go ahead and do that. My markings are not going to scroll when I scroll the background. The markings are not going to go with it. So if you need to take a screenshot or a picture there, go ahead and do that. And you can always back up and pause the video to do so. So I'm going to clear this, and we're going to move up. Excuse me. And now we're looking at angle IKJ. IKJ right here. IKJ. What kind of angle is that? Its center is, or its vertex is at the center. So that is a central angle. So that's going to measure the same as its arc, 45 degrees. Angle ILM. ILM. Kind of angle is that? Not a central angle because its vertex is on the circle itself. It's on that circumference. So this is an inscribed angle. So the measure of that angle is going to be 1/2 of the measure of its arc. So is it 1/2 of 45? There's 45. No, no, this inscribed angle goes all the way out to M. So we need to add these two together. 45 and 55 equals 100. So it's marking the arc from I to M, which is 100. So the measure of ILM, that angle is 1/2 of 150. Let's take a look at QP. QP. What do we know about what's going on here? Well, we've got some inscribed angles. We know that this inscribed angle in OP is the measure 80 degrees. So the measure from N to P would be what? 1/2 that? No, the angle is 1/2 the arc. So the arc is going to be twice as big as 80. That full arc would be 160. But we've already got part of the arc here, 100. So from Q to P then is going to be 60. 60 degrees. What about arc OP? Well, arc OP, I don't have an angle that goes directly to P here, but I do have one that goes out to Q. So I know that OQ is related to this inscribed angle, right? Twice as much as 70 is 140. And I know that QP was 60. So then OP has got to be 140 minus 60, which is 80. We're working our way all the way around this circle now. What is arc NO? NO. We don't have any inscribed angles that get us to NO. There is nothing that goes NO to a single point. But that's okay, because we actually have then, I'm going to take away some of these other figures we worked on. We've got all the measures of the remainder of the arcs of this circle, and we know everything has to add up to 360. So if we take 360 minus 100 minus 60 minus 80, I believe that's going to give us 120. 260, 200 minus 80 is 120. So arc NO is 120. Now angle OPQ, OPQ, what kind of angle is that? P is its vertex, and it's on the circle, so that's an inscribed angle. That's going to be 1/2 of this major arc here that goes all the way back around. So that's 100 plus 120 is 220, and half that, 110. 110 there. And then angle PQN, this last one, you can do the same for 120 plus this 80 is 200, and half that is 100. And a quick check, what kind of quadrilateral do we have here? OP, let's see, NOPQ, NOPQ. Well, it's no special kind of quadrilateral. It's just a quadrilateral. But we do know that all of the angles in a four-sided figure have to add up to what? 360, right? So if I wanted to double check here, 360, 100 plus 70 is 170. 110 plus 80 is 190. And if I add those two together, I get 360. So I did find the correct angles there. All right, so if you'd like to take a screenshot of this or a picture, go ahead and do that. And the main thing to remember here is that inscribed angles are 1/2 the measure of the arc that they intercept. 1/2 the measure of the arc they intercept. And on page 53 in your book, page 53, number 4 and 5 gives you an exercise that you can do in Desmos, or even just on your graph paper if you have a protractor. On page 53, number 4 and 5. And it'll help you to see why the inscribed angles are 1/2 of the intercepted arc. So if you have any questions, drop me a comment, and I will see you all again soon.